Hi, this is Courtney Hammond Wagner. I'm a postdoc at Water in the West, and I'd like to take this time to give you a brief overview of my research looking at integrating climate change into groundwater sustainability planning. As I'm sure you know, groundwater is an important resource. Globally, groundwater accounts for about a third of freshwater use. But perhaps more importantly, it plays a critical role in enabling societies and industries to weather climate variability and change. However, groundwater faces a number of key challenges. First, it's declining and critically overdrafted in many basins around the world. In this figure, you can see the declining trends in water storage in many of the Earth's major aquifers, and the yellow line here is California's Central Valley. Secondly, climate change is going to impact groundwater resources. It's going to impact it in a number of ways, but at a high level, it'll impact it directly through recharge rates of surface water into the aquifers, and then indirectly through impacting groundwater use for irrigation. Because of this, it's really important to consider and incorporate climate change into any groundwater sustainability process. But we don't have a good idea of what good integration looks like and what enables it. So California's Sustainable Groundwater Management Act, or SGMA, represents a unique opportunity to examine the range of treatments of climate change under the SGMA regulatory mandate to incorporate climate change into groundwater planning. And this leads us to our research questions. First, what is the range of integration of climate change into groundwater sustainability plans, the GSPs, in response to this regulatory mandate? Second, what are the enabling factors for integrating climate change into the GSPs? So to answer these questions, we're analyzing the 44 recently submitted groundwater sustainability plans submitted under SGMA in the critically overdrafted basins. So these basins highlighted in purple in the map here. Before we could start analysis, we first had to answer a broader question, which is what is good or effective integration of climate change into plans? Our answer to this question is a set of 6 criteria for evaluating climate change policy integration in the GSPs. First, is there internally consistent treatment of climate change in the plan? Second, are the goals developed with consideration of climate change? Third, do they account for local groundwater dynamics and complexity? Fourth, do they account for uncertainty associated with climate change? Fifth, do they account for risk in the selection of projects and management actions? And then finally, sixth, are they updating climate change knowledge to inform management? We're just getting started with the full analysis, but I do have some initial results that I can share based on reading a handful of the GSPs. First, we see that they're meeting regulation. Climate change is incorporated into their water budgets. But we see that the way climate change is integrated is not informing those interventions, the projects and management actions to achieve sustainability. Nor is the way climate change is integrated addressing some of the key concerns or drivers of undesirable results, such as potential impacts on the timing or duration of drought. On the bright side, though, there are some examples where GSPs are going above and beyond regulatory requirements to address local climate-related concerns. For example, Borrego, a groundwater sustainability agency in San Diego County, has carried out a rather sophisticated Monte Carlo analysis to identify the range of future variability in natural recharge rates. So they identified that this variability was critical to their sustainability, and so they carried out this analysis that goes beyond the Department of Water Resources' basic recommendations. So I'm looking forward to seeing how these trends hold up amongst the broader set of plans, and then down the line getting a better understanding of what's driving them. Broadly, my goal is for this work to identify how we can enable and support climate change-informed groundwater sustainability planning. So with that, I'll close, but first I want to say thanks to Water in the West for supporting this work, and especially thanks to my colleagues Tara Moran, Ben Bryant, and Xiaogong He for their contributions to this work. I'd also say please feel free to reach out with any questions or comments, and I've got my email here. Thank you.